So for this last one, this is a graphing calculator question from the AP exam. You will likely not have to do graphing calculator questions for the AP because I think there might be an issue around accessibility around graphing calculators for the exam. Okay, so what I'll do the graphing calculator calculations for you, but bear in mind that you don't have a graphing calculator on you. If you can use a graphing tool and get it to you, there's lots of tools on the internet. I think Desmos will do it. I think you kind of have to search one of the Desmos ones. But the graphing, if you want to follow along with the graphing calculator calculation, that's fine. But really what we are going to focus on for today anyways is we're just going to make sure we know how to set up the integrals, because that's likely what's going to be asked on the AP exam for this year, which is 2020, and with our all the circumstances around the COVID this year. Okay, so we have our two graphs here. We have our f and g functions. Okay, so that curve function here, and maybe I'll color code these. Okay, this is my exponential function. Okay, so that was going to be this one here, my f function, and then this would be my g function here. Okay, the polynomial function. Oh, that's terrible. Okay, there's my polynomial function there. Okay, so there's my g function. Okay, so that says find the sum of the areas and show the integrals involved. So I'm going to do part A here. So part A, is going to be the integral r, the area r, is going to be equal to, well, I need the top function over the bottom function. So we need to, I'm going to call that point A, and we would need a graphing calculator to solve for that intersection. Okay, because if we actually make this equation equal to each other, that's algebraically not solvable. So we need a graphing calculator to find that point. So we're not going to find that point. I'm just going to call it A so we can set up. So I'm going to integrate from 0 to A, and I want the g function on top because that is the upper function. I'm going to subtract the lower function, which is f of x dx. Okay, so that would be the area R. The area S is going to be integrating from A to the x value of 2, and now the red function is above the blue function, so we're going to write it as f of x minus g of x dx. So there it is. So those are the integrals involved in finding those two areas. So it says a region S is a base solid whose cross section perpendicular to x-axis is squares. Find the volume of the solid. So we're not going to actually calculate it again, because we'll need our calculator and the integral function on the calculator to do this. But we're going to show the integrals involved. So for part B, it looks like this. Okay, so for B, what we're going to do is we're going to take this distance here. So the cross section is perpendicular to the x-axis. So this length here is going to generate squares in 3 dimensions. So I'm going to try to draw a square in 3 dimensions. Okay, so that's going to be squares in 3 dimensions. So every cross section here is going to generate that square, and we're going to end up with a 3-dimensional solid generated from that. Okay, so it's going to kind of come to a point here. It's going to come up. You're going to have big squares here. It's going to again come back to a point there at x equals 2. So we first of all need to find out the length. The length between that black line there between f and g is going to be f minus g. Okay, so the volume that we're going to calculate is going to be f of x minus g of x. Okay, so I'm just going to write underneath, that's the side length of the square. To get the area of the square, we need to square that. Okay, and if I want to find the volume, I need to give it some thickness, or dx. And I'm going to integrate that from the tip here, A, all the way to x equals 2. So those are going to be bounds of integration. And again, A, we could have found, if with the graphing calculator, we could find that point A by just finding the intersection of those two graphs on the graphing calculator. Again, we would not have solved that algebraically because when we make these two equations equal to each other, it is not algebraically possible to solve for that. Okay, so that's part B. That is the solid, volume of the solid that's generated when I subtract to get the side length, square the side length to get the area of the square, and give that square some thickness to give it volume, and we're going to do it from the start A to the end 2.